Hey guys, so in this step we are going to investigate the introduction to the Fermi Paradox, which is explained in the first video questioning, are we alone in the universe? So I'm just going to give you a brief overview and later on we're going to go into depth about it. But we need some context for exposure before we really go into it. So this video is for that context. So what is the Fermi Paradox? So there's a great website over here called Wait But Why that is a website that's questioning and investigating interesting topics like this. And they kind of run down, feel free to explore it later if you want, but I'm going to kind of briefly overview this so you'll understand the Fermi Paradox and where we're going with it. So the Fermi Paradox at its core is asking the question that the physicist Enrico Fermi asked, which is, where is everybody in the universe? Like, are we the only life out there? We're looking up at the sky thinking, is there anyone else out there? And we try as humans to answer this question, but yet it's a wicked problem. There's no best answer to this because we don't have the technology in order to figure out if we are. Our current best bad solution is the Fermi Paradox, where we try and investigate the cases, specifically the three cases in which we try and answer, are we alone, or is there life out there? And in order to understand this paradox over here, we kind of have to understand a little bit about space and how big it is to try and mathematically wrap our heads around the probability of us being alone, either if we are or if we're not. So the Fermi Paradox is going to make us think about the size of space and different planets and try and help us figure out that even though the starry sky seems vast, are we in fact alone? So let's dive into this paradox after we learn a little bit about how big is space, because in order to really understand this paradox, we have to understand something about space. So we're going to go learn about how big space is. Before you do watch the video, I want you guys just to recognize that the human brain is very, very bad at visualizing numbers that are too large. And if I were to tell you to imagine what $1 billion looks like, you probably couldn't picture with like dollar bills how big that actually would be, or $1 trillion. And we're talking huge amounts of space. So I'm going to try and give you context of how big it is in this video. And in order to do so, we're going to start really, really small at a very small item. And then we're going to get bigger and bigger and bigger using comparisons to see how big things are. And that's going to help you guys kind of get a scale of the universe, even though it's really hard for brains to wrap around. Alright guys, so I'm going to pause that video, and now I want to slow down. I want to take a look at planet Earth. Now we just compared California, which is right over here, compared to the entire planet Earth, compared to some other planets in terms of scale. Now this scale is planet Earth, and this scale over here is comparing Earth in this diagram as a ratio of the Earth compared to everything else. So right now we only see planet Earth. And the reason that I'm pausing this to show it down is because this is completely incomprehensible for our brains to understand. So I'm going to try and break it down as much as possible so we truly understand how small we are. So we have California and we have Earth in this diagram. So over here, moving on to the second slide, this is the solar system. This little dot right here is planet Earth. And this little dot right here is the sun. Now, if we were to try and put a distance on this over here, the Earth is 93 million miles from the sun. So 93 million miles is the distance from right here to right here. That tiny little distance right there is 93 million miles. We cannot fathom that. I mean, it's not possible. But this entire diagram is at the same scale as the solar system. So in terms of our solar system, this entire area right here, the Earth makes up this little yellow dot compared to the sun, and we can see all of our other planets in relative distance to where we are. And even really, really, really big planets like Saturn, you cannot see in our entire solar system. And it only gets bigger. So take a look at not just our solar system, but the solar interstellar neighborhood. You guys see the solar system? Yeah, it's that little dot right there. You cannot even see it. I'll just put a dot on the screen just so you can see it. It's like right there. So that's our solar system compared to all of these other solar systems. That's a solar system, that's a solar system, that's a solar system. Like, these are all entire systems of suns with stars that are just like this one over here. So from that, it gets to our entire Milky Way galaxy, which is made up of solar systems. These things are all solar systems. You see this? Solar system, there's there's probably 100,000 solar systems in that circle right there. And of those solar systems, just one of those dots is our solar system. Like, this is really, really, really big. Then, if we go from our Milky Way, this is just one galaxy compared to all of the different local galaxies. Not even all of the galaxies, these are just the local galaxies. So our sun in our solar system is in this Milky Way galaxy, which we are one tiny dot of one of those things compared to everything else. And to make it even bigger, this is the supercluster. And the supercluster, if this is one local galactic group, that dot is this local galactic group. That tiny little thing is where everything we know that holds dear is close to us. Well, actually, technically it's over here, but yeah, point being, really, really, really small. And this is just the Virgo supercluster. There are other local superclusters where the Virgo supercluster is right over there. We know of another supercluster that's kind of close to us, not really close in terms of something we can comprehend, but there are so many superclusters. And this Virgo supercluster over here has our galactic group in it, that's that dot, which has our Milky Way galaxy, which has, I get what you are probably at this point right now thinking, how do I comprehend any of this? Well, this is in the same shape at a 1-to-1 scale as planet Earth, and this is our observable universe over here. And how to try and represent this observable universe is something that we're not going to be able to ever understand if that tiny little dot is this huge supercluster of difference galaxies that we can see. But what you can understand is our observable universe is something that's kind of shaped something like this, where perhaps our entire universe is this cutout over here of this diagram. So maybe this diagram right here between those two yellow lines is going to be, if I shade this part in, this area is our observable universe, which contains the supercluster, which contains this one, this one, this one, all the way down to our planet Earth. Now that you guys understand just how big our universe is and how little Earth is, let's resume the video. It's time to investigate the Fermi Paradox. Where is everyone, especially that space is so big?